Welcome to the course Digital Transformation and Technological Innovation. So, we are into the introductory module for this, that is fundamentals of information systems. So, we are into the last leg of this module. So, let us start. So, we are talking about the enterprise systems in the last session. So, in the next one and the most important one or the most common one that is there, especially among the medium to large size firms, you would see more often than not they would be investing into this kind of information system. So, what is this one? Enterprise resource planning or ERP system. So, ERP system, this is an information system with integrated modular programs. There will be lots of modular programs generally corresponding to or mapped to different business functions, either finance or HR or operations. So, there would be different business functions, and there would be integrated modular programs, and each modular program would be mapped to some of these functions. So, information system with integrated modular programs to manage multiple business systems. So, when we say multiple business systems, these business systems essentially we mean that different aspects, different functions of the business, that is HR, finance, marketing, operations and all that, right. So, to manage multiple business systems and for a single or multi-site organization. So, generally the way ERP systems are these products are actually being developed or being sold, right. They support for single or multi-site, so that thought process is already there, right. So, in case there is a multinational organization or transnational organization, so they can benefit from this feature of multi-site organization, right. So, what are the benefits of enterprise systems? So, one important benefit is eased adoption of re-engineered business processes, because ERP systems conceive the integrated modular approach. That means they integrate different business systems, that means they integrate different business functions. That means in one go whatever business process re-engineering might have happened for that ERP system adoption, that adoption can be achieved in one go. So, in a way it would be like one cycle of adoption of ERP systems, and then different business functions, different business systems would become familiar with it, would accept the different modules that are relevant to them. Then overall it can be considered as a eased adoption. So, one benefit of enterprise system is that eased adoption of re-engineered business processes, right. So, you do not have to worry about any business function left out. In one go most of your business functions, they are integrated and the adoption happens, right. Then another benefit that is there is that the timely data for decision making, right. So, if the data is only coming from let us say TPS, transaction processing system, right, then that might not be sufficient at times for the decision making, because there might be production related data that might also be needed to arrive at a good decision, right. So, therefore, ERP system facilitates that. They overcome this problem where you are not just having just the TPS, you are having all the you are covering all the business systems, all the business functions, and the data is coming from finance, marketing, operations, sales, from every part of it, and therefore timely data is available and analysis can be done and a decision can be made. So, timely data for decision making is facilitated. So, these are some important benefits of ERP system. Then moving on, next one is business intelligence system. Now, business intelligence system, this is an information system that is used to analyze data which might be stored in enterprise sources, or maybe the external data might also be there, right, to produce visual and other insights for data driven decision making. So, this is the module where analysis happens, where visual and other insights are generated with the help of latest advances that are there in terms of AI and machine learning. So, that will also be supported. Some analysts, some data scientists would be doing the modeling, might have created already a model base. Those models would be readily used, and therefore, the visualizations or other insights would be readily produced, and data is coming from enterprise sources, that is within the enterprise, and some external data might also be integrated into it for a better data driven decision making. So, BI systems provide the intelligence to decision maker to run their business, to plan for the future. For example, what's going to be the demand for a given product in the next year, right? So therefore, they need to look at their inventory and how to how to manage the shortfall or overstocking, and whether they will be able to cater to increased demand that might be there, or maybe if there is going to be less demand, then maybe they need to push out or come up with different policies, discounts, to be able to push items away from outside from the inventory, right. So BI systems would give hopefully use the data, and the analysis would happen in the right way, so that the those artifacts, visual and other insights, those are produced and a good decision is made, right. Next one is knowledge management system, or KMS, right. So what this is about? So this is a information system to capture and retain a specialized and collective knowledge for shared uses in the organization. So there is specialized and collective knowledge, but lots of people would like to benefit from that specialized and collective knowledge, and there is a shared uses that needs to be promoted in the organization. So more often than not, this scenario is seen in consultancy firms, right, because there would be so many consultants that would be working in these organizations, and their roles and job functions will pretty much be same, and therefore whatever one consultant has specialized knowledge or expertise in, that if that is shared, then the other consultants can also benefit. So overall, all the consultants put together benefiting from each other's specialized knowledge, making it more like a collective knowledge, and then they can maybe increase the revenues for their consultancy firms. So knowledge management system are also common in some of the organizations. Next is expert system. So what this is about? So this is also an information system to capture and contain the wisdom of experts and specialists on complex tasks, right. So this task is so this is slightly different from what we discussed in KMS. So KMS is like consultancy or customer facing or the client facing work, and where the knowledge about the clients also counts, right. Previous issues with the clients also counts, and other challenges that the consultant might face from different parties, all that will also go into the knowledge management system. But here in the expert system, we are not talking about that. We are talking about the complex tasks, right, and which are difficult to perform, but there would be certain experts, certain experienced people within the organization who might have been doing that for years, and therefore they have figured it out how to perform that complex task in a stepwise manner, right. So tapping into their wisdom and coming up with the simplified forms, right, in a knowledge base, create a knowledge base, come up with simplified forms, create a knowledge base for the benefit of regular users or the new users who would be, let's say it's a complex scheduling task, and the new user would find it very difficult. But if we are able to create the simplified forms, easy to follow steps in the knowledge base, then maybe new managers they can also do scheduling tasks for those things. One example is actually the scheduling example itself, the airline crew scheduling, right, which could be very complex because there are so many factors that go with it in terms of people moving here and there, aircrafts, their maintenance, and many other external events, the weather. There is so much of uncertainty that is embedded in a airline industry. So therefore, scheduling also becomes a slight of complex task, right. So an expert system can be designed where these kind of people who have been doing this and figured it out, their knowledge can be simplified for the benefit of new managers, new people who would be responsible for the same task. So this is the job of expert system. Then next is decision support system. So what is this about? Decision support system is an information system to test new ideas, initiatives or business logic, following a problem oriented approach before full rollout. So somebody within the organization comes up with a new business idea, whether the technological or scientific or business idea, right. So you would like to test that idea before rolling it out. So you would like to do a partial rollout or small scale roll out to test it out, test the idea, test the initiative, or test the business logic, right. So decision support system actually facilitate this activity, right. So for example, analysis of bundled offers, right. So if for some reason demand is on the lower side and the organization decides that maybe somebody gives the idea, maybe we can do bundling, and therefore we can push some of the demand for certain products, right. So bundling offers might increase the curiosity of the customers, the target customers, and therefore there might be a little bit of extra sales due to bundling. But how to figure it out, what would be the impact. So testing the impact of an idea, so that analysis is to be done somewhere. So decision support system provide that kind of support. Similarly for price promotion, so we would like to estimate returns of these initiative business logics. So decision support system are for this purpose, right, for testing out. Moving on, the next category is so we are moving away from from enterprise systems to AI systems, which are another set of category of information systems. Now there are so many advances that have happened over the years in AI domain. So that has created a number of information systems that we will discuss. So first step is robotic agent based system. That means robots are involved and there is some sort of AI component to it, and therefore it has sufficient intelligence and work like an agent, right. So what is this about? This is an information system to automate routine or risky tasks for productivity gains, right. So if there are certain routine tasks and now because of the AI sufficient intelligence, sufficient automation is feasible, so we can use these systems to automate those tasks. Or maybe if the task is risky and therefore productivity goes down because of the risk, because humans might be involved and you would like to cater to the human life and follow the ethical principles and all that, then if robots are used, then there would be productivity gains, right, because some of those human ethics would not apply to robots and therefore they can be used in risky situation, risky tasks, and therefore the productive gains could be there. So robotic agent based system, they would be very useful to automate routine or maybe risky tasks for productivity gains. So what could be the examples? So product movements in warehouses. So many of the the big e-commerce firms, they are managing their warehouses and there are so many orders that are floating around, and quickly you need to find that particular item and pack it, and all that needs lot more product movement within the warehouses, right. So it's a routine task, but if so many orders are coming, so to be able to meet that demand, meet those orders, timely pack, timely deliver, robotic agents could be used here. So product movements in warehouses and robotic agents doing this would be an example of a robotic agent based system, which is an information system. Then heavy vehicle durability tests. So heavy vehicle, they are supposed to be durable, that is the main selling point for them. So robotic agents could be used to do these durability tests much more quickly than a human driver doing it, right. So a robotic agent doing it would be much faster and maybe more tougher durability tests can be performed. So there would be productivity gains. That means a particular new design of a heavy vehicle or any other vehicle for that matter can be quickly tested because the risk is well managed because the robotic agents are being used. So robotic agent based system is another example of information system to automate routine or risky tasks. Moving on, vision based system. So this is also an information system that is used to automate routine or risky visual processing tasks. The focus is on visual aspects here. So vision based system, and if there are visual processing tasks which are slightly routine or risky, then in those cases also for productivity gains, so same logic holds for risky that we talked about for the robotic agent, and then there would be routine task where some sort of visual processing is happening. So we can use vision based system for the productivity gains. So what could be the example? For example, highway toll charges deduction. So there could be vision system which could be installed at the toll points, and then they will take the image number plate of the car or maybe some other reader, they could read that, or they could take an image and faster processing, visual processing for the toll, and the toll charges will be deducted from the bank account. So, all that automation is feasible. So, vision based system can be good option in this case. Similarly, we can think of many other scenarios, especially in law and order and many other similar scenarios where vision based system could be used. Similarly, in defense, space, law and order, where vision based system, we can potentially think about lots of examples where they could be deployed for automating routine or risky tasks. Moving on, next AI system is natural language based system. So, this is also an information system to automate conversational search, Q&A and control tasks for their customers. So, all of us we interact with some of these apps or some of these devices, for example Alexa, and we interact with that, and it catches our intent and plays that music that we want it to, right. So, in a way the interaction is happening through natural language, right. So, similarly we interact with the chat bots, right. So, there also the interaction is happening through natural language, whether typed or spoken, whether the audio or the text, right. So, examples here is the chat bots for search, queries, checking order status, changes in account settings. So, that would be the control part, order status that can be checked, that could be Q&A part, then search and queries, that could be conversational search part. So, natural language based system, they can be used to automate some of these tasks, and therefore the human resources could be utilized to some other more productive settings, right. So, overall because of the uses of chatbots and these natural language based system, there would be gains for the organization. Moving on, next is autonomous system. So, in autonomous system, this is another example of an information system. This is an agentic information system that can be used to automate action in response to its physical or informational environment. So, there are two environments that we talked about, the physical environment and the informational environment. So, for the physical environment, we can take the example of self-driving cars, where the self-driving cars can have the agentic information system, which is categorized as autonomous system, because based on movement of other vehicles that the sensor deployed in the self-driving car, they will catch, and using those sensors and other data that is coming in, the self-driving cars, they would manage, they will navigate through the highways or other places, right. So, that is a physical environment. So, the whole activity is happening in a physical environment, but it is an agent which is responding to the situation that is there in the traffic, in the highways, right. So, it is essentially an automating an action in response to what is happening in its physical environment, which is being captured by sensors and other devices which are installed with the self-driving cars, right. So, this is an example of physical. Similarly, there can be informational environment, right. So, in the informational environment again, for example we take this Google AlphaGo, right. So, this is a very good example of this, where Google AlphaGo plays with the top players of the game Go, and this is an informational environment. There are so many strategies how the pieces are to be moved and all that. So, if it is well trained, then it can strategize, but then it is playing as a player, as a computer player, right, as an agent, gaming agent, and then in response to the other player, the human player's moves, it will automate its action, right. It will strategize and then play its move, right. So, therefore, this is an informational environment. So, the agent is doing action in response to what the human is doing, right. So, this is another example, Google AlphaGo, another example of autonomous systems. Two examples we talked about within autonomous system, one for physical environment and one for informational environment. So, this is one more interesting example of AI systems and autonomous systems. Moving on, now while we talked about so many different systems, enterprise systems, AI systems, different examples that we talked about, right. Now, somebody needs to maintain these systems, develop these systems. So, we will discuss few pointers on that. So, we talk about the systems development. So, what is systems development is about? So, it is about developing new or improving existing information systems. So, we might already have bought or rented information systems, or might have developed within within the with using the resources of your own company, your own IT experts, right. So, you might have existing information systems. Improving that comes under systems development, and also developing new ones, right. There could be different needs and there could be different requirements, and new systems could also be developed. So, the system development is about developing new or improving existing information systems. Why we need to do that? We will talk about this. So, system development project, we understand few points on this. They can range from a small to very large, right. So, there could be simple apps that would also be there. They will also come under, will also be categorized as a system development projects, right. Similarly, there could be large complex enterprise systems also. For example, ERP could be considered one, because there are so many modules that need to be integrated, right. Then next is commonly these projects, systems development projects, commonly undertaken by firms across industries. So, it is not as if these are only prevalent in internet, social media and e-commerce and those firms which are powering the information economy. Now, this is space we are talking about the non-tech firms, the traditional industries also. They, to be able to run or support their business functions, business processes, they also have information systems. So, these system development projects are undertaken across industries, from a space to gaming industry, right. All kinds of industries, there are lots of information system catering to their own business needs. So, system development project is about that. Now, why do firms undertake the systems development projects, right. So, one could be simply they might have their own existing information systems, right, and there might be issues that they might have earlier identified through the feedback loops that we discussed earlier in previous sessions. So, there might be certain known issues, certain issues that have been identified. So, you might want to overcome those issues, you want to fix those issues. So, therefore, you have to undertake another system development project to be able to fix some of those major issues that might be there in your existing information system. Then there is some new organizational change, or some business need, new business need is there. Maybe you want to service your customer better, and for that some changes are required in the information system itself. And then there might be new organizational change, there might be new acquisition, new startup, or new mergers and all that, or there might be new department that might have been opened up, and the existing modules cannot be readily adopted for that particular function. There can be a number of such scenarios. To address a new organizational change or business need, also the organization might undertake system development project. Then similarly, so this was internal, right. The first one was related to issues, the problems. Second one is related to internal things, and then third one is related to the external, new regulatory or other compliance requirement. So, time to time regulatory agencies, they might come up with certain requirements that the firms in different industries, as it might be applicable, and they need to comply with. So, therefore, that compliance might have a bearing on the existing information systems. That needs to be able to comply to those requirements. The firms might need to make tweaks or changes in their information system. So, that might also be considered as a systems development project, right. So, to meet a new regulatory or other compliance. Then to adopt or benefit from a new technology. So, there are new technology that have they keep coming in, starting from cloud, mobile, blockchain, AI. So, there might be a strategic decision by the organization that they don't want to be left out, they want to maybe maintain their competitive advantage, or there is a competitive necessity out there, their competitors are adopting some of these new technologies. So, their customers might like that, better engagement, better interaction. So, therefore, this could be another reason to be able to adopt, make changes in their existing information systems and incorporate some of these technologies, so that they can compete well, right. So, these are some of the reasons why firms would take, apart from when for the first time an organization is trying to have an information system, then there might be a development from scratch. So, we will talk about this also. So, how do firms implement the systems development projects? So, there are two types of firms that we need to understand here for better clarity. One is tech firms. So, what are these firms? So, tech firms are firms that are partially or fully in the business of developing IT products and services. There are lots of tech firms, big tech firms from internet, social media, software, and many other industries which are into the business of developing IT products and services, right. So, obviously, whatever information system they need for their own consumption, they can build that, right. They are already building and rather selling it to others also, selling it to non-tech firms also. But then there are non-tech firms, their business is something else, their core business activities are something else, and they just need information system to support or run their business processes, business functions, business activities. So, non-tech firms are firms that consume IT products and services to support or run their businesses, right. So, this is another category. Now, when it comes to systems development project, it is these non-tech firms that we need to consider, because these firms, if they want an information system, they have two options. One is buy or rent, so they can buy or rent off the shelf IT products and services, because some of the tech firms might already have a existing IT product or service, because that is their business, right. So, some of these non-tech firms might find some of these IT product services fitting or closely matching their system needs, their information system needs. So, therefore, they can just buy that off the shelf, and that would be could be readily or immediately used, maybe some adoption time would be there, right. So, buy or rent is one option for rent non-tech firms. Then similarly outsource, if they want, if there is nothing is matching that is available off the shelf, then they might have to get their information system developed from scratch, but they are non-tech firms. So, then they can outsource that to a tech firm, right. So, that is one of the primary way of getting your system outsourced to a tech firm, and then sit down, look at the requirements of that new information system that is needed by the non-tech firm to support its business activities, right. So, then there would be the whole business of tech firms doing it, then there might be consultancy firm involved in between, and then non-tech firms who is actually the one sponsoring or getting this done, right. So, then moving on, then once we understood software development projects and system development projects in general, then what is the approach to it? So, that approach is system development life cycle, right. So, we talked about earlier there could be issues with existing information systems. So, that is typically referred to as system quality might go down, right. So, we need to manage system quality, and therefore, system development projects might be taken. So, to be able to better manage system development projects, there is a system development life cycle. So, what this is about? So, it defines all stages of system development in order to manage system quality, right. So, to better manage, so that the final information system is of higher quality or is having lesser issues, right. We would like to manage the system development life cycle, so that different stages of system development are well managed, and we hope that the issues in future would come down because of this stage wise management that was done. So, system development life cycle talks about this. So, let us have a look at the figure to understand this. Here you can see you start from here in this SDLC, this first phase, right, investigation and analysis system. You will study requirements, match, you will analyze what kind of information system that you need, what kind of system development project that you need to undertake. Then the design construction part will come. The design should match to your current and future requirements, it should be able to scale to your business expansion and all that. Then integration or testing, so that you are ready for that information system to be integrated to your existing information system, or maybe in production environment it should not be issues. So, that integration and testing is important. Then operations and disposition, so it will be deployed in the production or field setting, and then eventually maintained and retired. So, these are the different life cycle stages for a system. Moving on, so we are at the end part of this particular module, that is fundamentals of information systems, and the course is digital transformation and technological innovation. So, now let us touch on the innovation part. So, Digital transformation and technological innovation in particular serve as a catalyst for the business growth and success of any firm. Right? So, innovation is a key in terms of growth and success. So, why we need that? Because this innovation help us create and maintain sustainable profits. So, year on year we need to maintain profits to remain sustainable, to ensure business sustainability. So, innovation helps in that process, sustainable profits. Then provide added value for customers. So innovation might help customers, therefore indirectly it will help the organization. Raise new barriers for competition, because you are not acting alone in your own industry immediate environment, and therefore you need to do some innovation so that you are able to raise some barriers, new barriers continuously for your competition, so that you are able to maintain your firm's competitiveness and are able to avoid obsolescence. So these are some of the reasons why firms need to continuously innovate, and therefore the digital transformation and technological innovation becomes a catalyst for this business growth and success of any firm. Right. Now there are two types of technological innovation that we can talk about. One is sustaining innovation, right. So what sustaining innovation is about: continuous enhancements to existing products, services and business process. This is more of a continuous thing, continuous enhancement. So whatever you have, continue to keep on enhancing, keep on improving, right, because you need to increase your profits, lower your cost, gain market share. For any of these or all of these, you would like to do continuous enhancements. So this kind of innovation is referred as sustaining innovation. So whatever you are doing, sustain that through innovation, right. Then the next is disruptive innovation, and this is more serious, more important. That what happens here. So first starts with performance levels below the acceptance threshold, right. There might be some innovation, some product, some service idea, some innovative feature, something, and initially the performance level. So if it is a disruptive innovation, so initially the performance level will not be up to the mark, so they will be below the acceptance threshold. So the high end users, high end market segment or medium market segment might not be willing to buy that particular innovation, because performance level are below the acceptance threshold. So first this disruptive innovation will actually start with lower performance level than accepted. Then over time new characteristics might get added up, right, and these new characteristics might suddenly become too attractive to another segment of users, which might be more innovative, in a way more innovative category of users, or maybe it is a new market segment that got attracted to the new characteristics, right. So therefore the user segment, so that this innovation got a user segment, and then continuous improvements are happening. So this disruptive innovation, then continuous improvements, it might lead to higher performance levels, right. So when higher performance levels are there, then eventually comes the possibility of displacing the dominant product or services, because now this disruptive innovation is able to do what the existing or the dominant product services were doing. And now there are new characteristics, and they already got a user segment for that. And now the user segment for the dominant product, they might also feel that why they should miss out on the new characteristics while other segments are enjoying that, and they are not losing out anything, because for the dominant products, the features that are being given by the dominant products or services, they are also there in the disruptive innovation products, right. So therefore eventually the disruptive innovation will displace the dominant product or service. So this is the more threatening form of innovation, disruptive innovation. Then the concept of innovation diffusion comes in. So what is innovation diffusion about? Adoption of innovation does not happen all at once for all users of the target population, right. So when you come up with the disruptive innovation, so not all users might be enticed to it, not all users might be interested in it, because performance levels might also be issue, as we talked about. Then rather how typically it happens, it becomes a drawn out process where few user segments, there would always be user segment which are very curious about new innovation, new thing coming up, and they might quickly adopt that innovation quickly. There would be the first people who try, who are first tryers, right. So innovation, they adopt innovation more quickly than others, right. So slowly things will happen. So essentially the way innovation diffusion happens, we would notice different categories of users. Some user segments, they quickly adopt, they seem to be quite innovative themselves. They were curious about innovative things and they adopt, and then other user segments might follow because the performance might also improve for that innovation. So that is how the innovation diffusion will happen. So here is a figure that explains that. So let us say these are the innovators which are the first triers, and when things worked out, then early adopters will come in and they will say this innovation is quite good and good performance level, why not adopt that. So these are the people who would actually give the boost to this disruption innovation. Then there would be lots of people who would be following these early adopters because they might start forming the opinions in the different user segments. So there would be early majority, the people who follow them, and then eventually out of competitive necessity or out of not being left out, late majority will join in, and then there would be laggards who would also eventually will join in. So essentially we can figure out different categories of users and how the innovation diffusion happens, and that is how that is connected to the disruptive innovation that we talked about. Now finally let us talk about the IS or information systems roles and responsibilities. So first question is that how different are the job profiles of professionals who are working in IS roles and responsibilities from those in CSIT. So these are shared and overlapped. So the kind of job profiles are shared and overlapped with CS and IT. So the main difference is when you actually do it, you might be in similar roles and responsibilities, but you might be more closer to the business system. If you are in a IS role, you will feel more closer to business systems or end users, and the people who are into more CS and IT, then they will be more closer to the technology, right. So roles and responsibilities, they are shared and overlapped in terms of job careers, job profiles, but in case of IS roles you are more closer to business and end users, right. So similarly at the top level also, so CIO, Chief Information Officer, is more IS and CTO is more CSIT, right. So let us stop at this point, and that is also the end of this module, introductory module on fundamentals of information systems. Thank you.